In this video, I will go over all 6 questions in the Level 2 assessment for DNA replication. Question 1 says, on the model of replication below, label the leading strand and the lagging strand. The key to which is the leading and which is the lagging on this particular diagram is you can see this bottom strand has 3 segments that aren't connected, so that is your lagging strand. And this top part has 1 segment of the new DNA that is connected, so that's the leading strand. So our top's going to be the leading, the bottom's going to be the lagging. Okay, the next one, number 2, asks, on the model of replication below, draw a blue arrow to show the direction the helicase, draw a purple square to show one place where ligase would be. Well, we know from the previous question that this is the leading strand, so helicase looks like it's opening this direction, which means the leading strand will get copied in that direction. Ligase, the thing that needs the purple arrow, is going to be on the lagging strand because ligase is the glue that glues those segments together. So you could put a ligase square there, or you could put a ligase square there. Those are the best places for ligase. Question 3 says, on the model of replication below, label the 3' and 5' ends of the parent DNA and daughter DNA. If the top one is the leading strand, then the original parent DNA had to be 3' for the leading, which meant the opposite end of the parent is 5'. On the other side, the parent strand happens to be green, so that end of the parent strand has to be 5', and this other end must be 3'. For the daughter DNA, also has to be the opposite of the parent DNA, so this end here has to be 5' and across from it 3'. And the final daughter strand on the lagging side has to be 3' to be opposite of the parent, and on this end 5'. When everything is said and done, there are 1, 2, 3, 4, 5, 6, 7, 8, 5 and 3' labeled. Question 4. On the model of replication below, draw a red circle to represent the current location of the 2 polymerase molecules, one on the leading strand and one on the lagging strand. So again, we know this is the leading strand, which means it's copying in that direction. The bottom is the lagging strand, which means it's copying in that direction. Where do the polymerases end up if these bases have already been added? So polymerase added the C, the G, the T, the C, the A, and the A in that direction. So right now it's right here where this solid circle is. The next thing it's going to add is the base pair for that G up above. On the other side, though, remember polymerase is moving in the opposite direction. It's going to do this segment first. So it's going to add the copy to the G, the T, and the C. It's going to back up, do this segment second, add the copy to the AAC, then back up, add that final copy or that final segment last, so add the copy for the T and the G, which puts the polymerase right here. Okay, so it's important to remember 2 things on the lagging strand. Number 1, it's copying the opposite direction of the leading strand. And number 2, it's going to start with that segment that's closest to the end first and backtrack its way through. So where I have those 2 solid red circles is where the 2 polymerase molecules should be. Question 5. What are the next 2 bases that will be added on the leading strand in order? So again, our leading strand going this way, so that means first we need a pair for this G, so we're going to add a C, and then next we need a pair for that C, so then it's going to be G. That is the correct order if polymerase is adding bases in that direction for the leading strand. And finally, question 6, what are the next 2 bases that will be added on the lagging strand in order? So I just talked about polymerase being right here. Okay, now it's going to back up to the beginning of the open segment right here. It needs to pair up with this G first, because that's where our bond is broken. G is going to be paired with C, and then it's going to move, remember, this direction, and find a pair for the C, which would be G. So that's the correct order of bases that are added to the lagging strand.